Hi, my name is Kelly and this is my lab 2. So the objective of this lab was to determine the charge on a piece of tape using a more sophisticated computational model. This model will give a more accurate estimate of the charge since it breaks up the tape into several segments, and each of these segments are modeled as a point charge. So I redid lab 1, charge tapes, to gather the data to input into the computational model. The main physics principles used are electric field and force, as these charged pieces of tapes have an electric field and exert a force on each other, gravitational force, as this tape B, the floating piece of tape, does have an electric force pulling it downwards, and these two forces interact with each other through Newton's third law, which is every action has an equal and opposite reaction, so these forces have the same magnitudes and point in opposite directions. Also, superposition was a really important physics principle used, which is the net electric field at a location is the vector sum of the individual electric fields. This holds for forces as well, which is why we can break up this tape into different segments, calculate the electric force for each of those segments, and then add them together to get the net electric force. My experimental data was the length of the tape was 0.2 meters, the mass of the tape was 0.0002 kilograms, the separation distance was 0.02 meters, the magnitude of the gravitational force was calculated from F equals mg, which is 0.00196 newtons, and the magnitude of the electric force was 0.00196 newtons as well, because the magnitudes are equal to each other. So the computational code, the mass had been edited to reflect the mass that I got for my piece of tape. The charge was kind of moved around to get my electric force to equal my gravitational force, so I'll talk a little bit more about that later. The E field function was to create the electric field, and this function was just directly taken from my lab 0. All right, the line charge function hadn't been edited from the starter code, but line 75 and 76 have. So the starting position for top tape, the y component is 0.02 to denote the separation distance, and the x component was negative 0.1 for top tape and bottom tape, but that was just to center the diagram within the output. That had nothing to do with any of the computations. The axis for both of them, the x component is 0.2 because the magnitude of the axis was just equal to the length of tape, so the x component is 0.2. The E scale and the FE scale haven't changed. What I got to work for my code was 1 times 10 to the negative 6, and the electric forces and gravitational force was 75. In the double for loop, this is to calculate the electric force per piece of tape and to denote that arrow, and then to also calculate the net electric force. So as we can see here, line 119, this was the electric force per segment of tape. So F is equal to electric field times charge. So that's why it's the dq top dot charge times the electric field of dq top by dq bottom. And then FE on top just actually sums up all those different electric forces. All right, in line 135 and 139, these will denote the electric force vector and the gravitational force vector. So I had to change what the axis was, and the axis got changed to, for 135, the electric force vector times that scalar factor, and for 139, it was just the vector of negative m times g, which is just the formula to calculate the gravitational force times that scalar factor. Here's my code output. As you can see, all the green arrows denote the electric force on that particular point charge or tape segment. The magnitudes of the electric force and gravitational force do equal each other at 1.962 times 10 to the negative 3 newtons, and this is also seen as the size of those two arrows, the white and yellow arrows, are the same. So the magnitude of the charge on one piece of tape was 2.261156 times 10 to the negative 8. I found this from starting with my lab 1 value, which was 1.866 times 10 to the negative 9 coulombs, and then just kind of did a guess and check until I got my magnitudes for my forces to equal each other. The assumption made was each U-tape has the same amount of charge, evenly distributed along the length of the tape. So what if I had modeled each of my tapes as a single point charge like the previous lab and compare the different charges that you've gotten from both labs? So my charge from lab 1 was 1.866 times 10 to the negative 9 coulombs, and the charge for this model, lab 2, was 2.261155 times 10 to the negative 8 coulombs. The difference, percent difference was 91.75%. These two estimates differ because lab 1 assumed that the entire tape was a single point charge and lab 2 does not. The value from lab 2 is probably closer to the real value because it breaks up the tapes in many pieces and calculates each piece's electric force and adds them together through superposition.